Hi everyone. While we're waiting for the slides to load up, just a raise of hands. How many of you are from academia? Okay. And how many from industry? Anybody from government or NGOs? All right. So I see, at least I could kind of see maybe a larger proportion from industry and a sizable number of folks from academia. So while we're waiting for the slides to load, let me just give some feel for what we are doing. As I was introduced, I'm the chief scientist for the healthcare AI efforts at Oracle. So we have been looking at some of the challenges in healthcare, the challenges that clinicians face every day on a day-to-day basis. So these range from spending a lot of time on, say, the electronic health record systems, or spending a lot of time going through the patient records and so forth, and not being able to spend as much time face-to-face interacting with the patients. So that's the kind of broad problem we are kind of looking at solving. So while we are still waiting on the slides, so let me just give some context on where I'm coming from. So I have been at Oracle for almost 2 years, helping grow these efforts and launch our flagship product, Clinical AI Agent, and its variants. So before this, I have been, over the last 2 decades or so, working on problems related to trustworthiness, starting with data privacy, bias, fairness, explainability, AI observability, and so forth. All right, so here we have, okay, so let me start with some of the state of healthcare today. Today we have a number of different challenges. So we have the challenge of shortage of physicians, or more broadly, clinicians. We have the problem of burnout and administrative overhead experienced by clinicians. There are surveys showing, even before COVID pandemic, that about 80% of clinicians were experiencing burnout, causing them to quit the profession or planning to quit the healthcare industry as a whole. Then we also have, on the other hand, the amount of time that a patient gets to spend with the physician is reducing, because the physicians are asked to see more and more patients. And even in this small amount of, say, 15 minutes, typically the provider or the physician will be spending a good chunk of time looking at the computer and maybe not as much looking at the patient. And all of these factors, along with maybe several other systemic factors, result in a number of errors in healthcare, for example, resulting in as much as 400,000 preventable deaths in the US alone. And of course, these are not limited to US. These are problems in many countries across the world. At the same time, we are seeing that the healthcare costs have been going up. For example, in the US, it is estimated that around $1 trillion is associated with the administrative overhead or administrative burden in healthcare. So the natural question is, this is not sustainable. What can we do about this? How can we bring down the costs and also improve the quality of the care that the patients receive today? This is where I think that AI has a huge role. And in fact, this is not just thinking, AI is already being used across healthcare and being adopted rapidly. The challenge that we are looking at is, how can AI help reduce administrative overhead, clinician burnout, and so forth, so that hopefully it results in better patient outcomes. And since this is the domain of healthcare, how do we do this in a trustworthy manner? How do we ensure patient safety? How do we ensure that all the regulations are followed, and so forth? So with this context, let me kind of go more into what we are doing. As I mentioned earlier, our goal is to reduce the time doctors spend entering data or searching patient records or typing notes and so on, and instead spend more time interacting with the patient, which is the thing that the reason they came to the profession in the first place. Towards this, we have built and deployed a product called Clinical AI Agent, where we first focused on the task of automatically capturing the medical notes by listening to the doctor-patient conversation, of course with the consent of the patient and the doctor, and then building on top of this, automatically capturing various orders placed by the doctor, like x-rays, labs, medications, and so forth, and going beyond that, helping the doctor before they go and see a patient in terms of what is the summary or what is the gist of why the patient is there and what are the relevant parts from the patient record for that. To go into more specifics, like we have been building this to be voice first and multimodal, something that works across devices ranging from mobile or web interface, desktop, and so forth. And also in a way where it takes the provider context into account. It knows the preferences of the physicians as well as the patient context, the reason the patient is here, the history of the patient, and so on. And do this in a way which is as proactive as possible. For example, if a new lab report has arrived, we want to suggest what might be the next best course of action in terms of the care pathway for the patient, for example. There are a number of technical nuances behind this. Today, let me just give one example of this, just as a flavor of this. So by the way, here is a link to a live demo of this system. So one of the key components of our system is what we call the multi-agent orchestrator. Suppose that the doctor is looking at Samantha's record and wants to know how are her vitals trending. The doctor might ask, show me the recent labs. So given this query, we need to figure out whether we need to search in structured records containing the labs. Do we need to search over unstructured data like the medical notes? We need to take into account the UI context, the context of the patient, and so forth, and do this in a way which supports multi-tenant conversations. And to do this, even though this query might be simple, you can imagine a number of other settings, like are there side effects of the medications that Samantha is taking now? Or what might be the best course of action for Samantha given her past records and the new lab results that have arrived. To do this, the orchestrator has a library of tools and skills. It needs to decide which is the right one to invoke. Then it invokes those tools, and it also has different types of guardrails at the input side, especially if this is not doctor-facing, but say patient-facing, making sure that any queries which are sensitive or which require appropriate escalation due to medical emergencies are handled appropriately. Likewise, guardrails once we get the response from the agent on the output side. And then, of course, we also want the latency and costs to be contained. So we do a number of optimizations such as caching or parallel computations, or deciding when the query needs to be routed to a reasoning model, a complex reasoning model, and when a simpler language model or even a deterministic Python code would suffice to get the response. So making those decisions at runtime so that we save both the latency and the cost. Of course, there are a number of other optimizations that I won't be going into today. As we move towards not just a multi-agent architecture for a specific application, but a multi-agent healthcare system as a whole, there are, of course, a number of different stakeholders involved, ranging from patients, doctors, on the administrative side, the folks involved on the payer side, and so on. And of course, a number of systems, including the electronic health records, and different tasks ranging from search, document summarization, or understanding the medical coding and so forth. How do we do this in a manner where all these agents interact with each other? At the same time, there are aspects like a number of things that can go wrong. If you're interested, please take a look at the tutorial that we presented at the ACM conference on agentic systems and AI recently. Just to give an example, there are challenges around evaluation. The evaluation that works offline may not translate to online, either because the assumptions are no longer true or the distribution of the patients may have changed. We also need to make sure that we take the business metrics and map them to appropriate applied science metrics, which we can measure and iterate on. Then there are problems like omissions. If you are presenting a summary of the patient to the doctor, unlike, say, web search or other systems, here recall is extremely important. If you miss something which is medically pertinent in the summary, that can lead to patient safety. So while we are doing this, let me just illustrate this with another setting in the medical imaging scenario. So here the task is, how do we encode clinical workflows when it comes to something like chest X-ray interpretation? How do we leverage tools that clinicians use today and so forth? And again, like even in this work, we have an orchestrated agent. Then we have a number of sub-agents inspired by clinical workflows. There is something called ABCDE system in medical imaging, stands for airway, breathing, and so on. And we have the sub-agents which are invoked in parallel. And then there is a synthesizer which combines potentially conflicting results from these sub-agents and then decides what's the best course of action. Again, like, as you all know, healthcare is heavily regulated. So this motivates some of the other work we do, whether it's in the data privacy space or bias and fairness space. In the interest of time, let me skip this. And let me conclude with the following takeaway. In a setting like healthcare, it's very important to understand the domain, not just focus on model development, but also on the data validation, on the evaluation methodology, and so forth. And it's important to iterate with the clinicians, understanding their needs, having some early version out, and iterating based on that. And of course, we use frontier models, but those may not have all the healthcare-specific nuances. So building domain and task-specific knowledge and encoding these in the form of a semantic knowledge graph and semantic data layer is very important. And as I alluded to, trust, safety are extremely important. And here is just an example of a process we follow in the form of AI review for health. And let me conclude with this, and happy to talk to you offline if there are questions. Thank you.